Hello everyone, I am Dr. Sonia Juneja, Assistant Professor in Kite Group of Institutions, Ghaziabad. Today, I am going to start transverse nature of EM wave, then orthogonal nature of EM wave, then we will study the characteristic impedance of EM wave in free space, and then take an example. What is the mean of transverse nature of EM wave? When the vibrations of electric field and magnetic fields both are perpendicular to the direction of propagation of EM wave, called transverse nature of EM wave, means the vibrations of electric and magnetic field, when the electric field vibration and magnetic field vibrations both are perpendicular to the direction of propagation vector, then the nature is called transverse nature. When the nature is called transverse nature, in this nature electric field vector and magnetic field vector both are perpendicular to the propagation vector k. In this article we have to show that k dot e is equal to 0 and k dot h is equal to 0. When k dot e is equal to 0, it shows that k and e are perpendicular to each other. When k dot h is equal to 0, it shows that k and h are perpendicular to each other. Means both vibrations E and H are perpendicular to propagation vector k. Means EM wave has transverse nature. We know that EM wave in free space is given by del square E is equal to 1 by c square del 2 E over del t square. In terms of H, del square H is equal to 1 by c square del 2 H over del t square. These are the differential equation, and the solution of above equations can be written as E is equal to E naught e to the power I k dot r minus omega t, and H is equal to H naught e to the power I k dot r minus omega t. This is the solution of this equation. This is the solution of this equation, where k is the propagation vector and can be represented as kxi plus kyj plus kzk. E naught and H naught are the amplitudes of EM wave, where E naught is equal to E naught xi plus E naught yj plus E naught zk, and H naught is equal to H naught xi plus H naught yj plus H naught zk. R is the any observation point which is equal to xi plus yj plus zk. Then k dot r is equal to I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. Otherwise all are 0. Therefore k dot r becomes kxx plus kyy plus kzz. Now del dot e, del operator, it is equal to del by del x of I plus del by del y of j plus del by del z of k, and vector E is equal to E naught e to the power I k dot r minus omega t, where E naught is equal to E naught xi plus E naught yj plus E naught zk. Then del dot E becomes del by del x of I plus del by del y of j plus del by z of k dot E naught xi plus E naught yj plus E naught zk into e to the power I k dot r minus omega t. Again I dot I, j dot j, k dot k is equal to 1, otherwise all are 0. Then del dot E becomes del dot E becomes E naught x del by del x of e to the power I k dot r is equal to kxx plus kyy plus kzz minus omega t plus E naught y del by del y of e to the power I kxx plus kyy plus kzz minus omega t. Similarly, E naught z del by del z of e to the power I kxx plus kyy plus kzz minus omega t. E naught x, E naught y, E naught z are the amplitudes, does not depends on x, y, z. Therefore, del dot E becomes E naught x into I kx. When del by del x operates on e to the power I kxx plus kyy plus kzz minus omega t, then we have E naught x I kx into e to the power I kxx plus kyy plus kzz minus omega t. Similarly, y part E naught y I ky e to the power I kxx plus kyy plus kzz minus omega t. Similarly, z part E naught z I kz e to the power I kxx plus kyy plus kzz minus omega t. Then del dot E is equal to E naught xi kx plus E naught y I ky E naught z I kz into e to the power I kxx plus kyy plus kzz minus omega t. Then del dot E is equal to I k into E naught e to the power I kxx plus kyy plus kzz minus omega t. Then del dot E is equal to I k E naught e to the power I k dot r minus omega t. E naught into e to the power I k dot r minus omega t becomes E. Then del dot E is equal to I k dot E. Similarly, we have to show that del dot H is equal to I k dot H. But from the Maxwell first equation in free space, del dot D is equal to 0, del dot E is equal to 0. When del dot E is equal to 0, left hand side becomes 0. Then I k dot E is equal to 0. Eta cannot be 0. It is equal to under root minus 1. Therefore, k dot E is equal to 0. Similarly, we can show that k dot H is equal to 0. When E and K are perpendicular to each other, when H and K are perpendicular to each other, then the EM wave has transverse nature. Orthogonal nature of EM wave. What is orthogonal nature? We have to show that vector k, which is the propagation vector, and vector E and vector H are perpendicular to each other. In the previous article, we have shown E and H are perpendicular to vector k. In this article, we have to show that E, H and K all are perpendicular to each other. For this, we have to calculate del cross E. Del cross E can easily solve by determinant. Then del cross E is equal to ijk. This is the x component of del. This is the x component of E. This is the y component of E. This is the z component of E. Then after solving this determinant, we get this equation. Then after operating a del by del y, del by del z, del by del x on this equation, we get this equation. Then del cross E is equal to I E naught z ky minus E naught y kz plus j E naught x kz minus E naught z kx plus k E naught y kx minus E naught x ky into iota e to the power I kxx plus kyy plus kzz minus omega t. Then after the previous equation, del cross E becomes I E naught z ky minus E naught y kz. This is the I component, this is the y component, this is the z component into iota e to the power I kxx plus kyy plus kzz minus omega t. Then this is the cross multiplication of k cross E naught. Then del cross E is equal to k cross E naught into iota e to the power I k dot r minus omega t. We know that E naught into e to the power iota k dot r minus omega t becomes E. Then del cross E is equal to I k cross E. Similarly, we can show that del cross H is equal to I k cross H. We know that from the Maxwell third equation in free space, del cross E is equal to minus del B over del T, which is equal to minus mu naught del H over del T. Substituting this value in this equation, we have minus mu naught del H over del T is equal to I k cross E. Then I k cross E is equal to minus mu naught del by del T of H is equal to H naught into e to the power I k dot r minus omega t, which implies I k cross E is equal to minus mu naught, H naught is constant, H naught into minus iota omega into e to the power iota k dot r minus omega t. Then we have iota k cross E is equal to minus mu naught minus I omega H, which implies I k cross E is equal to iota omega mu naught H. Then we have k cross E is equal to omega mu naught H. This equation shows that E and K are perpendicular to each other. E and K are perpendicular to vector H, because we know that when the cross product of two vectors is equal to the third vector, then both vectors are perpendicular to the third vector. This equation shows that E and K are perpendicular to vector H. Similarly, k cross H is equal to minus epsilon naught omega E. This equation shows that H and K are perpendicular to vector E. From both equations, we can easily say that K, E and H are perpendicular to each other. This is the orthogonal nature of EM wave. In the orthogonal nature of EM wave, E, K and H are perpendicular to each other. we can easily solve by determinant property. In the previous slide, K cross E, from the previous slide, K cross E is equal to omega mu naught H. Then 1 upon omega mu naught into K cross E is equal to H. Then 1 upon omega mu naught n cap into K. K is the magnitude of vector K. In cross E is equal to H. Then K upon omega mu naught n cap cross E is equal to H. Then n cap cross E is equal to vector E, and omega by K is the velocity of EM wave in free space, which is equal to the speed of light. Then 1 upon mu naught C is equal to 1 upon mu naught C E into E is equal to H. Taking modulus on both sides, we have E by H, which is known as characteristic impedance Z naught, which is also equal to E naught by H naught is equal to mu naught C. Substituting the value of C in terms of mu naught and epsilon naught is equal to under root mu naught by epsilon naught, which is equal to 376.6 ohms. Means characteristic impedance is equal to E by H, which is equal to 376.6 ohm, and also equal to under root mu naught by epsilon naught or mu naught C. This is the example. If the magnitude of vector H in a plane wave is 1 ampere per meter, and find the magnitude of E for a plane wave in free space. We know that in this article E by H is equal to 376.6 ohm. Substituting the value of H, then E becomes 376.6 volt per meter. Thank you. If you have any query regarding this lecture, kindly mail me at sonia.juneja@kite.edu.